All right, this is going to be our walkthrough for the homework assignment titled Extra Continuity. So we're just doing some more of these continuity problems where we're looking for values of a and b so that the function that's given is continuous for all real numbers. And so we'll note that all three pieces of this are always continuous. We just then need to make the limits match up at 1 and at 2 for this function. And so we're going to start off then by doing the limit as x approaches 1 from the left of f of x, which will be 3 times 1 minus 5, or negative 2. And then we'll also do the limit as x approaches 1 from the right of f of x, right, which means we're just plugging it into the ax squared plus bx plus 1 portion, which becomes a plus b plus 1 when x is 1. And then in order for the limit as x approaches 1 itself to exist, we then just need a plus b plus 1 to equal negative 2. Or in other words, we need a plus b to equal negative 3. So there is one of the equations that we need to be true in order for this to be continuous for all real numbers. A plus b needs to equal negative 3. And so then we'll go in and we will do the same thing at x equals 2 and get another equation that we need to be true. So we'll do the limit as x approaches 2 from the left of f of x, which now that goes into the ax squared equation. So if we put in the 2 there, we end up with 4a plus 2b plus 1. And then as we do the limit as x approaches 2 from the right of f of x, that's just 2 times 2, which is 4. So when we put this together, we have 4a plus 2b plus 1 needs to equal 4 in order for the limit as x approaches 2 to exist. Or in other words, 4a plus 2b needs to equal 3. So we need both of these things to be true in order for this function to be continuous for all real numbers. So in order to figure out when both of those things are true, we just need to solve that system of equations. So we'll start with 4a plus 2b equals 3, and recognize that if I multiply everything in a plus b equals negative 3 by either 2 or by negative 2, we can do either one, we should be able to get some b terms that match up and cancel out if we either add or subtract them. So I'm going to multiply everything in a plus b equals negative 3 by 2, which gives me 2a plus 2b equals negative 6. Right? So that's coming from this a plus b equals negative 3. And now I can just subtract 4a minus 2a is 2a, 2b minus 2b is nothing, and 3 minus negative 6 is 9. So we end up with a equals 9 halves. And if a is 9 halves, well, then we'll just plug that back in here. 9 halves plus b equals negative 3, or b is equal to negative 3 minus 9 halves. Negative 3 is negative 6 halves, so if I do negative 6 halves minus 9 halves, that's negative 15 halves. And those are our values of a and b that make this continuous for all real numbers. For our second one here, we're just going to use the same basic process. We're just going to look for the limit as x approaches 1 from the left and from the right, and then 2 from the left and from the right. So the limit as x approaches 1 from the left of f of x should just be a plus b plus 1, right? Just plugging it into the top part here. And the limit as x approaches 1 from the right of f of x, well, that comes from this, which will be 2 plus a plus 2b. So in order for the limit as x approaches 1 to exist, I need a plus b plus 1 to equal 2 plus a plus 2b. So what I'm going to do here right off the bat is I'm just going to bring all the variables to one side. I'll bring them all to the right-hand side, and all the constants to the left. So if I bring an a over here if I subtract an a from both sides, the a's just cancel out. And if I subtract a b from both sides, I get a b on the right-hand side. And if I subtract a 2 from both sides, I get a -1. So we just get b equals -1. So actually, that's really quite useful. Now we know that b is equal to -1. And so when I do my limits for 2, I can remember that 2b, right? 2b is actually equal to -2, right? So we can say the limit as x approaches 2 from the left of f of x should be equal to 2 times 2, which is 4, plus a minus 2, right? Or just 2 plus a. And then we've also got a limit as x approaches 2 from the right of f of x, which should just be the 3x minus 3, so that'd be 6. 3 times 2 minus 3. 6 minus 3 is 3. So really all I need is for 2 plus a to equal 3. Well, that just tells me that a must equal 1. All right, we're going to use the same process here. So this time we're looking at limits at -1 and at +1. So we're going to start with a limit as x approaches -1 from the left of f of x, which will be 2 times -1 plus 1, which is -1. And we'll also do a limit as x approaches -1 from the right of f of x, which will be -1 squared is +1, so positive a, and then minus b. So what we need is for a minus b to equal -1. So that's one of the sets of equations that we need to deal with. And then we've also got a limit as x approaches 1 from the left of f of x. Well, that'll just be a times 1 squared, or a, plus b times 1, which is just b. And as we do the limit as x approaches +1 from the right of f of x, that should just be the natural log of 1, which is 0. So we now have a plus b is equal to 0. Those are the two equations that we need to satisfy in order to make this thing continuous for all real numbers. Well, those are already set up nicely. If I add those together, a plus a is 2a, -b plus b cancels out, and -1 plus 0 is -1. So we get a is equal to -1/2. And if a is -1/2, well, we know that -1/2, or a, plus b needs to equal 0, so b must just be 1/2. And of course, this is just the same type of problem. This time we're going to deal with this when x is 0. So we'll start off with a limit as x approaches 0 from the left of f of x. Well, if we're plugging in 0 for x, we end up with 0 plus 0 plus 4 in that first one, which is just 4. And if we do the limit as x approaches 0 from the right of f of x, we end up with a times 0, which is 0, plus 2b plus 2, which of course is just 2b plus 2. Well, right off the bat, we know that 2b plus 2 needs to equal 4, which tells me that 2b equals 2, or b is equal to 1. So I know that b is equal to 1. So now when I do my limits of 3 from the left and from the right, I can treat 2b, right? 2b is just going to be 2 times 1, or 2. And bx is just going to be an x, right? Because b is already 1. So we'll do that. We'll do a limit as x approaches 3 from the left of f of x, which will be 3a plus 2 plus 2, so 3a plus 4. And then we'll do a limit as x approaches 3 from the right of f of x, which will be, well, x is now just, or the bx is now just x, or which is 3, so we'll put in a 3 for that. So 3 minus 2a plus 5, which will just be 8 minus 2a. So we already have b equals 1, and we can see that there's no b's left. We just need 3a plus 4 to equal 8 minus 2a. And so whenever that's true, should be a solution. So 5a equals 8 minus 4 is 4. So we end up with a is equal to 4/5. And we've just got one more of these here. So for this one, we're going to, again, use the exact same process. We'll do a limit as x approaches 1 from the left to begin with. So 2ax squared will just be 2a, and then plus 1. And then we do the limit as x approaches 1 from the right of f of x. Well, that's going to be 3 times 1, which is 3, plus a plus 2b. So what we need is 2a plus 1 to equal 3 plus a plus 2b. If we try to get everything to one side here, we'll end up with, if we subtract the 2a over, right, we're going to have a negative a plus a 2b on the right, and on the left we'll have a negative 2. So we're going to start off with negative 2 equals negative a plus 2b. And then on the other side, with the value of 2, we'll do a limit as x approaches 2 from the left of f of x, which will be 3 times 2, or 6, plus a plus 2b. And we'll also do a limit as x approaches 2 from the right of f of x, which will be 4 times 2, which is 8, minus a minus b. So what we need is 6 plus a plus 2b to equal 8 minus a minus b. Well, if I put all of that onto all the variables to one side, that'll be 2a plus 3b if I bring them all to the left. And if I subtract the 6 over, we end up with 2a plus 3b is equal to 2. Right? So we've got two different equations. Negative 2 equals negative a plus 2b. And we've got 2a plus 3b equals 2. So we want to find a way to solve this. There's, of course, a lot of good options. I think this time, since we've done all the other ones with combination, we'll do this one with substitution. If I solve for a, we have a is equal to 2 plus 2b. And what I'll do is I'll just plug that in for my a value. And we're kind of running out of room here. So we're going to have 2 times 2 plus 2b plus 3b equals 2, right, if I replace that. So see if I can remember that onto the next page. We'll have 2 times 2 plus 2b plus 3b is equal to 2, right? That's what we got when we just substituted the 2 plus 2b in for the a. And so that tells us that 4 plus 4b plus 3b equals 2, or that 7b is equal to negative 2, or that b is equal to negative 2 over 7. And if b is equal to negative 2 over 7, well, we knew that a was equal to 2 plus 2b, right? So that would just be 2 plus 2 times negative 2 sevenths. Well, that'd be 14 sevenths minus 4 sevenths. That means that a is equal to 10 over 7. And that is the end of the homework assignment titled Extra Continuity. Hopefully that was useful, and we'll certainly see some questions on the test like these.